Hi, welcome to the lecture 3 of a structural system, which is of wind and seismic analysis. So here outline of module has been already discussed, and in which the above four topics has been already discussed in lecture 1 and lecture 2. So today now we are discussing about the strength and stiffness. So first I'll introduce what is the strength. So strength is a measure of how much stress that can be applied to an element before it deforms permanently or fracture, or we can say in other terms that strength represents how much load the member can resist before it fails. So strength is a measures of stress, that how much stress can be resisted by the elements before it fails. And in another definition, strength is called as an ability of material. If we are talking in terms of material, then it's an ability of material to withstand an applied load without getting plastically deformed or a rupture. So here are three definitions of a strength. Now there are some important definition of strength that you have to be keep into your mind. One is a yield strength. So as you have already studied these type of strengths in your subjects, strength of material, but now again I am describing these strengths. So yield strength is used in material that exhibits an elastic behavior. It's the maximum tensile stress that the material can handle before going for a permanent deformation occur. So this is the yield strength. Another one is ultimate strength. It refers to the maximum stress that can carry by a material before failures occurs. So before failures, the maximum stress which is carried by the material is called the ultimate strength. And last one is the fracture strength. So fracture strength is the value corresponding to the stress at which total failure occurs. So at the time of failure, the stress is carried by the material is called the fracture strength. Now from this graph you can understand that what is the yield strength and what is the ultimate strength of the material and what is the proportional limit. So in the proportional limit is when the stress is directly proportional to strength, or when the removal of applied load from the member or from the material, then the material or element regain its original shape. It's called a proportional limit. And yield strength is before material is going for a permanent deformation, then it is called a yield strength. Stress carried by the material or a element, then it is called a yield strength. And the maximum strength which will be carried by the material or element is called ultimate strength. From this point you can see the ultimate strength, which is the maximum stress carried by the element or the material. And the fracture strength when the material is going to fail. So from this figure it is clear that how the different type of strengths. Another term is stiffness. So stiffness is an indicator of the tendency of an element to return to its original form after being subjected to a force. So when the force is applied, the material gets deformed, and after the removal of that load, the material regain its shape, or element regain its original shape, that it's called the stiffness of that element. Another definition, it is called it's a measure of how much force is required to displace a building by a certain amount. So that how much, for a certain amount of displacement, how much the force is required to applied on that building is called the stiffness. In another definition, stiffness is the degree to which an object resists its deformation in applied load. So when the load is applied, then how much deformation is resisted by the element or a material, then it is called stiffness. And how it represents stiffness can be expressed as follows, that K is equal to F divided by delta. It means for a unit displacement how much force is required, K. So here K is the stiffness, F is the applied force, and delta is the deformation. So now in this picture it is showing that when there is a no load, then the shape of beam is showing by a dotted line, and even after when the force is applied, F is applied in this beam, then beam is deflected in a downward direction, and the amount of displacement is delta. So the stiffness of this member of this beam is K equal to F divided by delta. So what are the difference between strength and stiffness? There is a lot of confusion between strength and stiffness, how they are different. So first one is the strength generally depends on the modulus of elasticity. It means when the load is applied, the structure is get deformed or displaced, but after removal of that load, the structure or member can regain its original shape, then it is called a stiffness. And strength depends on some material yield strength or its equivalent. So strength depending on the yield strength, and stiffness depends on the modulus of elasticity. The second one difference is the stiffness refers to the amount of deformation under the applied load. Okay, and strength represents how much load the member can resist before it falls. So stiffness is the resisting of that deformation. So how much the deformation can be resisted by the member due to the applied load is called stiffness, and the strength is called how much load can the member resist before it fails. So there are two differences between strength and stiffness, and here you can understand from this picture that this region is showing the stiffness of the member, and this region is showing that strength of this member. So strength is the load resisted by the member before it going to fail. So before going to fail, the load resisted by the member is this. So from this region it is showing that this is the strength of that member, and from this region you can see that here is a stiffness. So within the elastic limit, the material behavior or element behavior is known as the stiffness. So this is a graph between the design lateral force, which is H, and lateral deformation, which is delta. So if the lateral force is acting on a building element or a building, then how much the deformation will occur in the building element is lateral deformation, and how much is the load carried by the member before failure, then it is called strength. So to understand the difference between strength and stiffness, here I am taking an example of a chalk and piece of rubber. So we are considering a piece of chalk and a piece of rubber with the same cross-sectional area and the same length. So the dimensions of the chalk and the rubber are the same. If we are trying to bend the piece of chalk, it does not deform, but it can break. So why it is breaking? Due to having its low tensile strength. Therefore chalk is having large stiffness but low strength. Why? Because it is not going for a deformation, or a displacement. It is not going for a displacement, but it's break. So breaking is done before, so that it is having a low strength and the stiffness is large. On the other hand, if the piece of rubber, if the same amount of load is applied on the rubber, then rubber easily bends, but it does not break or fail, even it is folded. So therefore, compared to chalk, rubber is having a low stiffness but high strength, because it's a bend. The rubber has been going to a bend or a folded, but it will not break. So the load carrying capacity of that rubber before going on a fracture, it is high. So it is having a high strength in compared with a chalk piece. Now if the building material, building elements or a building is subjected to any kind of load, then it going to be deteriorated with the time, and it does not perform well when it is subjected to a lateral forces or any other forces. So what are the some strengthening techniques that we can adopt to improve its load carrying capacity? So first one is jacketing of column. We can done jacketing of column to improve its load carrying capacity. If the column has deteriorated due to moisture ingress or some amount of cracks has been cracks some amount of cracks on the columns, then columns strengthening can be done by jacketing. We can place a wire mesh around the column and then place a new concrete on that column. Then the strength of concrete can be increased to its design strength. Second one is post tensioning of existing beams. If the existing beams cannot perform well when it is subjected to a flexural load or a lateral load, then how the strengthening of a existing beam can be improved? So it can be improved by the post tensioning. Third one is the introducing the lateral load resisting element. If the building is subjected to any lateral force, which is a seismic force or a wind force, then the building, how the building can resist these type of lateral loads. So we can provide a lateral load resisting element such as shear walls we can provide around the building, so that they can resist that lateral loads and enhance the capacity of a building. Fourth one is the underpinning of footing. So if the building is subjected to any kind of lateral load, then it can slide, it can overturn, or it can slide. So if the sliding of building whole the building is done, so to prevent this sliding, we can done underpinning to the footing, so the sliding can be prevented by this method. Fifth one is the local replacement of damaged concrete and steel. So as the concrete is damaged or steel is damaged, then it can be replaced by some new concrete or some repair technologies, so that they can perform well. Why the concrete and steel will be damaged? So there are some failures due to shrinkage and creep, or corrosion will start in a concrete due to moisture ingress, so that the steel will start corroding and it will not perform well. So we can replace that concrete and steel by a new concrete and steel, so that its strength can be increased. Repairing cracks by injection of epoxy grout. Some of the minor cracks that can be repaired by special techniques, which is epoxy grout, which will set soon and perform well. Its strength is very good, so we can inject that epoxy grout into that cracks, so that building will perform well. And last one is the shortcutting. We can done shortcutting also. So these are some strengthening techniques. Other than, there are a lot of strengthening techniques that we can use. So here I am listed only as 7. So we can done some strengthening techniques, and the building can perform well. So here are some references. Thank you.